Right, good morning. So today, this is our last lesson of quantitative chemistry. I'm sure some of you will be thrilled to hear. Tomorrow we are going to be doing quick check questions, and then it'll be Mrs. White again next week. So today's lesson, calculating concentration using moles. Don't know why that's not clear. There we go. So there are a couple of things here that we need to remember. This lovely analogy, which I laughed about and then we all realised I quite liked. So horse to fly multiply and fly to horse divide, of course. So just as a reminder, this is small, that's bigger. So this is your fly to horse, divide, of course. Horse to fly, multiply. There I am, forgetting it. Okay. Now, you'll notice that on here we've got millimetres, metres and decimetres. Centimetres is actually a really horrible unit that sort of fits in between these two here. So centimetres to metres, fly to horse, divide, of course, but it's only by 100. Metres to centimetres. So it's just worth remembering that this is our general pattern. This is just a horrible unit that fits in the middle. So what we're looking at here, or what calculation concentration using moles, you'll have probably seen this when we've done experiments before. You'll have seen the name of the acid, and then you'll have seen underneath on the label there will have been a number. Okay, that number is always then ended with a capital M. M actually represents the concentration, and the way we work it out is we do moles per decimeter cubed. So moles divided by volume. Remember, I've taught you how to do those units before. So moles divided by volume is actually how we can work out the concentration of something. If we put that into a triangle, of course, moles divided by volume, so we need moles divided by volume. So concentration fills that final box. There are 3 steps to this equation. So number 1, check the volume is in decimeters cubed. Convert if it's not. That's always your first step, conversion. Second thing, use the triangle to work it out. So obviously if you want to work out concentration, you cover that up and you would do moles divided by volume. If you wanted to work out moles, you would do volume times concentration. And if you wanted to work out volume, you would do moles divided by concentration. Okay. So let's have a look at some questions. I've done one of each just so that you can see what they would look like. So what is the concentration of a solution that is 2 mole and 5 decimeters cubed? So we're working out the concentration. So to work out the concentration, using my triangle, I know that I do mole over volume, mole over vol. So I'm going to do 2 divided by 0.5, which gives me an answer of 4. My unit for concentration is a capital M. That's all I need to do for that first one. Question number 2, what are the number of moles in a solution with the concentration 0.7 M and 0.4 decimeters cubed? So this time I'm working out the moles. So moles equals, using my triangle, volume times by concentration. So this time my volume, 0.4 decimeters cubed, that's the correct unit. I don't need to do anything with that. So I'm going to do 0.4 times by 0.7, which gives me an answer of 0.28 moles, mole or moles. Final question, what would be the volume in meters cubed? So I've got an extra step in my equation here, of a solution with a concentration of 5 M and a molarity of 12 moles. So what would be the volume? So volume is equal to mole over concentration. Remember, using my triangle. The mole is 12. The concentration is 5. So that would be 2.4. Remember, my standard unit for this is decimeters cubed. The question has asked for meters cubed. So I need to get from decimeters cubed, which is a big unit, to meters cubed, which is a small unit. So I'm going from horse to fly, horse to fly, multiply. It's not that horrible centimetres unit, so it's by 1,000. So I'm going to do 2.4 times by 1,000, which gives me 2,400 metres cubed. In an exam on this last one, if you stopped at 2.4 decimeters cubed, you would get 2 marks. You'd get a mark for doing this bit correctly because you've understood, you know, how the triangle works. So you'd get 1 mark for this bit, 1 mark for that bit. This would be worth a 3rd mark in chemistry. So just bear in mind that if it asks for a different thing, if you can't quite remember how to convert it, if you need to use the volume in the equation, you need to make some effort to convert it first, otherwise you don't get anything. But if it's at the end, you would only lose the final mark. Right, I hope that all makes sense. Questions are on the PowerPoint again. Answers provided to yesterday's lesson. Hope you're all well. Speak to you tomorrow. Bye.